They may still take 5 or 10 minutes to turn up as usable for the meeting, so we might ask Scott to just use his screen share or whatever.
Okay, sounds good. So doing it at the moment.
So we'll get started in a minute or two, folks. We're just doing a bit of slide shuffling. And for generally for folks, if you're not presenting or talking, it's probably good just to not send video for the moment. Okay, so I see Scott's slides now.
In Miteco?
No, and on mail.
Yeah, I'll upload them to the data tracker. So
okay, let's have a quick look and see. Do they show? I think they'll take a while to show up, but we'll see.
Yeah.
Oh no, they're there.
They are?
Yes, they are. Look, there we go. Okay, so we'll go back to the share slides, and I think we're good to go. So, hi everyone, welcome to the Lake Interim. My name is Stephen Farrell. Militia did all the work for this meeting, so I'll let him have the joy of talking about the various chair slides.
All right, so next slide, please, Stephen. So yeah, this is an IETF meeting, so the note 12 applies. Please be aware of the IETF policies, and we did not have any behavior issues in the past, so I don't think we should spend too much time on that. So we can go ahead with the proposed agenda for the meeting today. So here it is. So the first thing on the agenda is the agenda bash of this proposed agenda. So we will have a presentation on PAICS by Scott, followed by this open discussion on do we need a PAIC for ad hoc, and then preliminary evaluation results of draft Lopez Lake ad hoc PSK 01 by Elza Lopez. And then we plan on discussing the next steps and what concerns the IETF 121 planning in essence. And then, of course, followed by any other business. So, Christian, do you want to bash this agenda?
If there is time, I'd like to take some time out before the AOB to ask on whether Greece has a future in this working group, because from my point of view, that document is done. So I'd like to put that in there.
Sure, thanks, Christian. And I think there's a link in the notes, but if you can probably just replicate that link in the chat, that'd be good. Also, in terms of notes, we have the usual note-taking tools, and I think Christian has volunteered to take some notes. Thank you, Christian. If somebody else is willing to join in, that would be nice too. We don't need blow-by-blow notes. We just need to kind of record any decisions or whatever. So if somebody else is willing to jump in, that'd be great. Otherwise, I'll try and keep an eye on it myself. Thank you, Marco. So I guess we have notes, we have that AOB, and back to you, Militia.
Yeah, so I guess we can go ahead with I think we have two open discussions, one on next steps and one on the ad hoc for PAIC, which we can compress. So I think we can add this to the agenda. For me, it's fine. So at the very end, just before the AOB slot, we can discuss the future of Greece in Lake. So with that, I hand it over to Scott with the first agenda item, which is the presentation on PAICS. Scott, the floor is yours.
Okay, thank you. I'm Scott Fleur, a cryptographer over at Cisco Systems, and one of the things I'm interested in is PAICS and how they can actually improve security.
Scott, would you like me to give you control of the slides, or would you rather I move them along for you?
Let's see. Can I have control? It'd be easier.
It's on its way to you.
Okay.
Thank you.
Okay. The reason for this talk, of course, the reason we're here is that Lake is going to extend ad hoc to include pre-shared key authentication, both for session resumption and possibly for just raw initial authentication. Password authenticated key exchanges, PAKE, can have better security for initial authentication, but it also has higher costs. And the goal of this presentation is to give you guys information so that you can make an informed decision. A top-level summary of the current ad hoc proposals, and this actually covers both variant 1, variant 2 of the current proposal. They both perform an anonymous ECDH operation, and then they stir the PSK into the derived keys. And then they exchange data, encrypted data using those keys, and they assume that if there's a mismatch, they'll catch it, and therefore the exchange will fail. And because of the ECDH, someone listening in can't learn the PSK because it's all secret. And past communications are secure, even if the PSK happens to be leaked in the future, because again, the ECDH saves you. However, there is another weakness. Suppose someone had a dictionary of 1 billion possible passwords, and the correct one is somewhere on the list. What they can do is do an active attack, posing as one of the sides, either the initiator or the responder, and based on what they learned from the exchange, they can then offline scan through the dictionary and find that password. Here's how it would look like in a variant 1. Variant 2 is similar, it's just that the rules are swapped. We have the attacker, which actually acts as the initiator, sends basically what he would do is send the first message completely honestly to the responder. The responder would then come back with the required EAD2 reply. And if you take a look, I've highlighted MAC2 in red. The reason that is in red is that the attacker knows can actually, because he's done it honestly, he knows the encryption keys, and so he can read everything. The only thing he does not know is the PSK, and that's the MAC2 is a function of that. And so what he can do is go through his dictionary of a billion passwords and see which ones makes that MAC2, see what he saw. If he finds it, he knows the PSK and then log in. Is this weakness important? It is in two cases. It is not. If you're doing session resumption where the password is like 16 or 32 random octets, this attack is infeasible because no dictionary is that big. And if you can somehow insist that the password is always strong, for example, a password manager, typically if you use the password it selects, it gives you a strong one because you don't have to remember it, then you're okay. However, if this is a human selected password, it is not, because humans are typically very bad at picking strong passwords. They typically pick ones which they can remember and that are too onerous to type in. So here's a more secure way for human-generated passwords. Password Authenticated Key Exchange. It is essentially binding together the key exchange and the password so that they cannot be separated, which is really what is the vulnerability with the current proposals. It's done such a way so that to check a password, he actually has to do an active attack and try that password and see if it succeeds or fails. If he has a dictionary of 1 billion passwords, that means that he would, to try them all, have to try 1 billion different login attempts, and that is completely infeasible. 1 billion passwords scanning through an offline attack in a dictionary, if they take 1 microsecond each, 1 billion passwords takes 20 minutes. Very feasible. 1 billion passwords online, if each login attempt takes a second, you're talking decades. And now, limitations and costs. Now, the PEG can't help you if the password has absolutely no security. For example, if the password you write it on a sticky note, attach it to your laptop, again, PEG's not going to save you because the attacker knows the password. And there are also some costs. There is a larger change to ad hoc than the existing proposals, which means there's more code changes, etc. It'll take longer to specify and to make sure that it meets all security goals. And its cost is that it uses more exotic crypto than what you're currently using, and it also doesn't do anonymity because, of course, because the password and the key exchange are combined, which means that the responder has to know which password to use to actually which PSK to use, and that has to be done before the actual key exchange. Now, the question is, are the costs worth it? I believe the next session will be next discussion will be about that. The CFRG activities. The CFRG about 4 years ago started to investigate various PEGs to see which ones we should be endorsed for IETF protocol use. There are several ones out there, and we just want to know which ones we want to recommend. And at the end, they selected 2 PEGs. One is called CPACE, which is a balanced PEG, which both sides know the password, which I believe is what you would use. And then they selected OPEG, which is an augmented PEG, which only one side knows. And and I'll get into exactly how that works later. Neither of our RFCs yet, but it shouldn't be too much longer. CPACE. What this is effectively is it's basically an elliptic curve Diffie-Hellman exchange. Just similar to what you do, but the key point is that instead of using a public generator that everyone knows, it uses a generator selected based on the password. And that's a simplified explanation, but that's the core of it. And both copies uses their password to generate the generator, and then perform the ECDH based on that generator. If they have different passwords, they'll pick different generators, and it just doesn't work at all. And the nice thing is that just by looking at which value you used, you have no idea which generator was originally used or which password was used. There's a number of details with CPACE about various things you need to check. Those details are not optional. Again, PEGs tend to be a little delicate, and you got to get the details right. Here is, I looked at how ad hoc how it would fit into ad hoc, and here's one, I won't call it a proposal because for honest, I just looked at ad hoc, and I need to make sure that I got all the protocol things right. It would actually, here is the first 3 exchanges. It would be in ad hoc. The red part at the first message are the 3 additional ones replacing, I believe you call it GX or XG. It was the ID credential because the responder needs to know which password we're going to use. YA, which is what CPACE calls their Diffie-Hellman share. Y is the secret generator, and SID is just a random value that the initiator picks because CPACE insists on some randomness in with the Y computation. Going back, basically it's same as a regular ad hoc, except that you use the responder selects a value based on the private secret generator, not the public one. And there's no reason to send the ID cred R and MAC2 because I believe those are used to to transmit credentials, and there are no credentials here because it's a PSK, and if you can decrypt it at all, you have the right PSK. And again, in the third message, you get rid of the cred I and MAC3, because again, you already have the credentials are I know the password. This yields relatively minor changes to the protocol. However, CPACE does use more exotic cryptography, specifically on converting the password and SID into Y. That is, it uses the obvious ways to do it just does not work. It uses a function called alligator, which which is not commonly used in most crypto library, exported in most crypto libraries. There's another protocol called opaque that CRFG endorsed. But it is assumes that one side knows the password, the other side does not, and there's an issue. And this is, I'll show you the next slide, which basically gives it. It shows you what it does. It's on a register. There's a registration phase where where the client registers and basically sends an encoded version of a password, and server says okay and stores some information. And later, when it's time to do a login, it tries to do the login, and it says also more encoded information. And if the password it used in the login happens to be the same password is when it registered, then you gets the secrets, and you can the server lets the client log in. Again, I don't know if this particular model meets the password management that Lake was thinking of. You can tell me. And I've went on for quite a while. Are there any questions? And remember, the whole point of this talk is for me to give you information, so any questions are quite welcome.
Great, thanks, Scott. That was very clear. And just as a reminder for people, if you want to hit the little button that looks like a hand to join the queue, that's the way to do it. Thank you. And Paul.
Hi, Scott. Yes, I have one question, because you didn't talk about the different strengths between PAKE and PSK and which variant is stronger. It is my understanding that if you would be using like a 32-byte random value for PSK, then it would be stronger than PAKEs, right?
Oh yeah, if you just used random 32-byte value, there's no need for a PAKE. You can get either your variant 1 or variant 2 is be perfectly secure.
Yeah. So I guess if there's some sort of automated provisioning system, that might be better than using a PAKE. But like you said, if there's a human involved, it's probably better to use
exactly. It depends on exactly who actually chooses the passwords. Computers are very good at picking very strong passwords. Humans are not.
Right. So I guess the question is, should both variants be supported or just one, right? That's a question that depends on the use cases.
Yeah, and that's something for the working group to decide.
Thanks.
Thanks, Scott. Great presentation. I agree with everything you say. At least can just talk for me, but my use case when we have thought about PSK was resumption and then external PSK, where the PSK is machine generated in some way and strong. Feels like the PAKE is I completely agree. If any human is involved, the current PSK version are not good. And if somebody wants to do password in ad hoc, I think that might be a good idea. But I think maybe they should. I think then we're probably looking at two different ad hoc methods. I don't think this. The PAKE approach is a good replacement for the PSK. but I would be happy to do both. That might be a good outcome, actually. Yeah.
Okay. That sounds like a more of a question, a comment for the next discussion, which is what do we do? What does the working group do with pigs? Ignore them.
Yeah.
Use that's the only option, or maybe having multiple options.
Yeah, this might have been completely fitting more in the next agenda item, but yeah.
Göran?
Yeah, trying to find the button. Okay, so thanks, Scott. Great presentation. So I'm a little bit. Haven't seen the use case for this yet. So I'm open for input here. I think the main use cases we've seen for ad hoc so far is very much IoT based, where one or both endpoints is a device, perhaps a constrained device, or communication is over some constrained link. So, for example, onboarding a new device, a sensor, or some microcontroller or something. And most of those devices don't have a human user interface. So it's not really clear how the password would make sense there. So I think I'm sort of more in favor of the other type of onboarding situation where you assume some secure random number to start with if you're using PSK.
Okay.
So that's my view.
Okay. So, any more questions or? Oh.
Yeah. So thanks, Scott. I guess we are now into the next agenda part. So if people want to have other thoughts as to whether we have use cases for this, might have in future, whether we're happy with the PSK current stuff really having strong keys, etc. So now's the time to kind of talk to that if you want to join the queue. And I know some people have spoken to it already, so just seeing who else has thoughts.
Rafa, you can go.
Yeah, okay. Can you hear me?
Yes, we hear you well.
Yes. Well, I said that in the chat, but actually, in my mind, when we discuss about the ad hoc PSK, in my mind was always the case where you have a high enough entropy key that is provided, so you can run ad hoc PSK, and not because I didn't imagine any password use case taking into account the IoT environment. So for example, checking TLS 1.3, they have a text about something I had in mind. Actually, they say that an outbound provision P-share key, a critical consideration is using sufficient entropy during the key generation. So I think mentioning that should be enough to meet some security properties here, because it has been recognized that is pseudo-random pre-share key should be enough to meet security requirements. Yes, that.
Thank you. So we have Christian in the queue.
Yeah, I do agree with that being an odd case, at least for the deployments that were considered. But I don't think that saying key has to be high entropy is what we should put in the PSK document. I think we should point to this material that that Scott has presented here and say that if there is ever a use case where someone wants to use this with passwords, this is not the right method. Here you need entropy. If you want to do it, like there is an avenue, but it was not explored so far because of, and that way someone using it has a way out.
Okay, thank you, Christian. So essentially what you're saying is that we should expand on the security considerations in the, which is for now the PSK document, but still an individual submission, but not close the doors for a password-based authenticated key exchange that we can standardize in the future. But also saying clearly, stating that this particular method should be used with the high entropy keys. Is that kind of what you're saying?
Yes, it's like either have high entropy keys or follow what we were not following here.
Okay, thank you, Stephen.
Yeah, so just a question. I guess people seem fairly clear that using high entropy keys much better, simpler, all good. Using human memorable passwords terrible, and you may need to have a PAKE. Do we have use cases that are anywhere in between with codes printed on the back of things that have to be typed by humans? And if so, do we, for such a use case, if we had it, do we think that warrants use of a PAKE or not?
So I hear no comments on this, on the use cases, but it's an important question. So I would encourage people to think about it, whether they have such use cases in mind. Paul is commenting, let's go for QR codes and not MAC addresses to type.
Sure, but then it depends what's encoded in the QR code as well, right?
Yeah.
So yeah, I mean, is anybody able to speak to those kind of use cases? Do they have those kind of use cases where it's a label on a thing or a QR code, and we might be in between human memorable passwords and high entropy keys? Yeah, so Christian pointing out a QR code can be a high entropy key. Of course it can. And equally, a 32 octet string can be a human memorable password. So can be is not so much what I'm trying to get at is like likely to be. Okay, so nobody's confessing that they have 4-digit numbers on the back of printed on the back of devices. So that's probably good.
Okay, so do we summarize the discussion, Stephen, or as I think the group agrees essentially on proceeding with the PSK-based authentication, where it is clarified in the draft that the PSK is a high entropy key that can be used in the protocol directly, as it seems to be an assumption right now. And then if there are further interest in PAKEs, we should explore the use cases more and see if somebody has a compelling use case to bring to the working group. And we can consider then in future whether we want to standardize a PAKE for ad hoc. Would that be kind of along the lines of what everyone has been saying?
Yep, that sounds like it to me. And possibly we might want to include some reference to PAKEs in security considerations in the PSK document. Not a huge amount of text, but a bit of pointer and guidance.
Okay. So I have a +1 from Christian. Does anyone else sounds reasonable from Rafa? +1 from Joran. So it seems, yeah, we have consensus on this one. There's Paul in the queue. Paul?
So I guess I still have a question. If most of these devices are limited in the number of simultaneous connections or the number of connections they can process in a certain amount of time, would it be possible that a PAKE is basically always strong enough so that there's no disadvantage to using a PAKE compared to a true random pre-shared key? Because normally the attacks are like, it's a TLS server and they can have like whatever, thousands of connections or millions of connections. But with these devices, we tend to only have a handful of connections, per minute. So maybe a PAKE is always stronger And in which case, it might make sense to just say, let's do PAKE and not just a random PSK.
All right, so we have Christian in the queue and then John.
I wouldn't support the statements that these devices always have a few connections. Ad hoc is quite suitable for connections between devices and servers, and you can have a server that supports millions or even billions of ad hoc connections on one side, and each of their peers only supports 2 or 3. So it's not necessarily a few connections case.
Yeah, it is. PAKEs are always better. Is a bit questionable. Like you lose the identity protection, which I think is quite important. And then, as Scott's point out, it's more exotic cryptography, which means might be more room for implementation errors, and also I would say that this little bit more exotic cryptography might be a little bit less trusted, but I haven't looked at the details of CPACE, and at least that's the case for earlier PAKEs like SRP or what the name was. Yeah.
All right, thank you, John. So I guess I wouldn't want to expand the discussion on the crypto properties of PAKEs here. I think we can keep it to the usefulness of PAKE for our particular use cases that we are considering in Lake and for ad hoc, and then we can of course CFRG is more competent to discuss the internal details of PAKEs. With that, I would close the discussion. Stephen, did you want to?
I just wanted to say again, thanks to Scott for I thought that was a really good brief presentation on PAKEs and their relevance for us. So I just wanted to thank him again.
Yes, so same here. Thank you, Scott, and thank you on behalf of the working group. So with that, we can close the discussion and proceed with the next agenda item, which is the preliminary evaluation of ad hoc PSK-based authentication method by Elsa. Elsa, do you hear us?
Yeah.
Okay, we hear you well. Thank you. The floor is yours.
Okay, so hello everyone. So the goal of this presentation is to present the current status of the 2 proposed variants and some of the preliminary results of ad hoc implementing both variant 1 and 2. So a bit of a summary of what was discussed on the previous meeting and what's written in the draft. Right now, we have 2 proposed variants in ad hoc using pre-shared key authentication. The main difference between these variants is where the ID cred PSK is sent. So in variant 1, we are sending the credential in the first message in the clear, whereas in variant 2, the authentication is delayed until message 3, and the ID cred PSK is sent in message 3 encrypted. There are some other differences as well, such as, for example, variant 1 does not include a MAC in message 2, and neither of them include a MAC in message 3, contrary to the stat authentication method. And in both cases, the message 4 is optional. Okay. So what I've been working on basically was the integration of the pre-shared key 1 and pre-shared key 2 variants in the current Rust implementation of ad hoc, so in Lakers. The goal has been to merge this pre-shared key with the already supported stat method, and then to evaluate both and compare them both using the NRF 52840 hardware. So this hardware uses a 32-bit on Cortex and M4 processor, and it runs at a frequency of 64 megahertz. It also includes a compatible radio for wireless communication, and we are using the embedded TLS library as a crypto provider. So in software, so I have been trying to run the code using the crypto cell, but it's still not working. So for now, we're using the embedded TLS library. Some additional parameters that have been used for the evaluation, we are using the Cypher suite 2. So this means that we are using the elliptic curve Diffie-Hellman on curve P256. The hash function is SHA256, and we are also using AES-128 CCM as the authenticated encryption algorithm. So the metrics that we are going to be measuring and comparing for both variants are security and privacy, message size, energy consumption, memory consumption, and the number of operations of both variants. So here are some of the preliminary results. So for the message size, I've measured the message size using Wireshark, which is a network analysis tool that allows us to intercept the messages on the wire. So we see that for variant 1, we have this extra byte that comes from the ID cred PSK. Then for message 2, we have 9 extra bytes, and this comes from the MAC 2. So we have 8 bytes for the MAC and then 1 byte to indicate the length of the MAC. And then message 3, we have 5 extra bytes in variant 2, and this comes from the concatenation of those 2 ciphertexts. One is the encryption of the ID cred PSK, and the other one is the authenticated encryption with additional data. So in total, we have for variant 1, 93 bytes, whereas for variant 2, we have 88 bytes. As for the number of operations, we counted the number of asymmetric and symmetric operations. So in both variants, in message 1, we have an asymmetric operation, which comes from the Diffie-Hellman computation. For message 2, we have 1 asymmetric and 2 symmetric operations in variant 1. The symmetric comes from the MAC and the encryption. And in variant 2, we only have 1 symmetric and 1 asymmetric since there's no MAC. Message 3, in variant 1, we have 1 symmetric operation coming from the encryption, and in variant 2, we have 2 symmetric operations since we have 2 ciphertexts, and then message 4, 1 symmetric operation. So in total, we have 2 asymmetric operations and 4 symmetric operations for both variants, so the number of operations is similar for both. As for the memory consumption, this is still on process. So we intend to measure flash and RAM memory and both static and dynamic memory. For the static memory, we did it both using, so at first I used the size command of the GNU toolchain, but that includes all the memory, including all the code, even the crypto backend. So what I've done recently is to filter the map files to only include relevant data to the code, to the Lakers code. In this case, to measure the memory consumption, the code was coded separately for each variant, so that we only had pre-shared key variant 1 and pre-shared key variant 2 separately. And on the table, we see the results for the static memory consumption for both variants. We have, we have the flash memory and the RAM. I'm not very sure about these results yet. And then for the dynamic memory, the goal is to measure it using the memory painting, but this is still on process. So I do not have results for this yet. And then for the energy consumption, this was measured using the power profiler device, so the OTE ARC. This measures the current consumption and the time, and with those 2 values, we can get the energy consumption. Here I measured both pre-shared key and the stat method to compare them. Note that the time is a bit longer since we're not using the crypto itself, so some operations take a bit more time. And here we can see So for each of the variants. So on the left we have variant 1, on the right variant 2. So yellow we have preparing message 1, then the initiator waits till it has a message from the responder, and then it parses the message 2. And we see that for the responder, when it's actually listening and waiting to receive, the current consumption is higher. And yeah, so the first method for the initiator, like time-wise, it's quite similar for both of them. And also the charge is as well similar. It's a bit lower for the pre-shared key method 1 compared to the second one. And then the security and privacy. So well, these are some of the most obvious results in terms of identity protection. Obviously, variant 1 offers less protection since the ID-cred PSK is sent in the clear message 1. Nevertheless, the authentication timing happens earlier in variant 1, and that could be an issue for some applications. And then, computational overhead is going to be higher in variant 1 since we're including separate encryption and we're including additional MAC2 compared to variant 2. And well, this is basically it for now.
So we have a question from Scott and then Rafa.
Okay, it's not a question, it's more of an additional comment. One of the things I forgot to mention during my presentation was variant 2 seems to be a little stronger than variant 1 against dictionary attacks. With variant 1, the attacker would need to actually mimic the pose as the client, which is an IoT device, fairly easy. In variant 2, it would actually need to act as a responder, which I believe is physically more difficult. Obviously not impossible, but it gives a little higher bar to how difficult the attack would be. Now, high entropy passwords doesn't really matter. For human-based passwords, in case someone does in fact use a human-based password, even if we advise them not to, that may be give them a little more protection.
Thank you, Scott. Rafa?
Yeah, Elsa, can you go to slide number 5? It's just a suggestion because in particular, it's just, by the way, thank you so much for all this information. Really useful. And just a suggestion about the message side, because I don't know if we have agreed on that or not, but you're including variant 1, 3 messages. And in variant 1, with those 3 messages, you get initiator mutual authentication between initiator and responder, and implicit key confirmation. With variant 2, you haven't included message 4 or any additional message to get responders authentication. So to me, somehow there is something missing there, maybe.
Okay, yeah.
Just to mention that, because after that, in the number of variation, you include message 4.
Yeah, you're right.
So I know it's preliminary results, but just maybe to take a look at this.
Oh, yeah. Impressive amount of simulations you have done, and like interesting to see that PSK is the second variant is better when it comes to performance. Think it could be good to notice that the bytes and the performance might be a bit preliminary, at least in the ordinary ad hoc. There was a lot of changes that affected bytes and stuff. but typically to the better. But there might be less changes here. My personal opinion is that identity protection is very important, but it would be good to try to make the specification as good as possible, and then I assume we're aiming for formal verification where something could pop up.
Okay, thank you, John. So for now, just as a clarification, this is an individual submission, but we seem to have a lot of interest around this draft, and comments. So it's good that we are discussing this. Elsa, do you want to recommend? I mean, people seem to be in favor of variant 2. This is what I see in chat and based on Scott's comments as well. So if you can go ahead for the moment, as it's an individual submission, and choose whatever you like. But this seems as a very well-informed decision to make at this point.
Yeah.
This I see Joran's +1 to variant 2. John, Scott commented.
So just a question for I guess for Elsa and other folks involved in this work. Is it the case that you would like to select one of the two variants and continue work on that, or are you happy to continue work on both, or what's the preference?
So I guess that it would be better to choose one of them and then focus on one of the variants. But for the moment, I was just working on both and seeing how both worked and compare them.
And then a follow-up question is that not necessarily only for you, Elsa, but at what point do we think we should make a decision? After the thing is being adopted, after we've seen some formal proofs, or what's people's feeling as to when would be the right point to try and down select to one, if that's what we want to do?
Sorry if my microphone is still clipping. I will try to not speak so loudly, but I think I'm not sure when to choose one or two. I think there will be more interest in doing formal verification for academic researchers when this is working group adopted. So I think it's I'm also biased in this, but I think it's close to being could be working group adoption. I don't think we need to wait for formal verification. That could come later.
So we have +1 from Christian on working group adoption as well. This is not a question we opened, but it's under discussion, I guess, now. Stephen, do you want to call this for adoption now, or would you like to wait? What are your thoughts?
It seems to be something that people are interested in. I'm not personally sure what the right point in time to do that is. But not a million miles away. But
so perhaps an item to discuss at 121 in Dublin.
Oh, for sure, yeah.
Yes. So which is close, which is in November. So by that time, we let the authors go ahead and publish a new version by the cutoff, obviously, which seems to make sense. It seems to be the case that the working group is preferring variant 2. So then I would recommend going for that variant and then kind of focusing the activity on that variant. And then on the point of formal verification, this will need to happen at some point, but I don't think we should condition the the adoption by the formal verification. In case there are no further comments on this one, I propose we skip ahead with the next agenda item, which is essentially the discussion on preparing 121 meeting in Dublin. So I think a lot of folks will be attending, will be on site in Dublin. One first question is, do we want to request a 1 hour or 1 hour 30 hour meeting for Dublin? So we have in the charter, we have remote attestation work that is ongoing, zero-touch provision, zero-touch joining that Joanne has been leading. We have the PSK draft that we are hoping to see in Dublin as well. So and that seems to be quite some topics for discussion. So yes, Göran?
Yeah, I've asked people in Uppsala University to talk about some fast testing. They've been some tools for fast testing. I don't know if they will come, but so that's one topic. Another topic. Yeah, I mean there will be some new drafts coming up as well, I think. So yeah, at least one more draft.
So that you seem to be favoring 90-minute meeting. So we have plenty of time for discussion, because 1 hour can be a little too short for given the new items, and if there are new drafts coming up, for sure it could be too short. So does anyone object requesting 1 hour 30-minute meeting in Dublin? I hear no objections, so the chairs will take an action item to request this meeting by the end of the week, which is the deadline. And then we will reach out to the working group regarding the agenda items for that meeting. The next item on the agenda is Christian, the one that Christian proposed during the agenda bash at the beginning of this meeting. Christian, do you want to give a summary of the status of the draft, perhaps?
Yes, I can. I'm happy to give a very, very short summary. This is about registering extensions that don't do anything but are registered so that it is ensured that they do not collide with any actual use, and they are just there for the same purpose as Greece is in TLS. That is to ensure that if someone starts using extensions that are optional, not everything breaks down, which both concerns implementations and firewalls. I think it's mostly just a matter of registering code points. I think the document is pretty done. I've presented it at least at one IETF meeting. So to me, the question is a bit like, is there anything that I should do going on this? Or is this something that the working group wants to continue? Is it something that the working group does not want to take up and I should rather take it to the ISE? I think it's just like we have a minute or two for this, and if I could get the input there, it would help make progress on this.
So as a reminder, we have this in the charter of the Lake Working Group, so I think it does make sense to keep it in the working group's hands. What the next steps with respect to the draft would be the working group adoption, I believe. Since you presented it, I propose you make an update to this draft, and then we discuss it in Dublin and decide on the working group adoption over there. Would that work for you?
Works fine for me. Thank you.
Stephen, anything that you would like to add?
No, I mean, I think that makes sense. I guess I'd be interested to know how many people had read this and the previous document as we're discussing them. So.
Yeah. So we're not calling for adoption now, but I see plus ones in chat for the moment from John. So yeah, we've discussed it, and there was some interest during one of the previous meetings. I remember. I don't remember which one exactly, but I remember the presentation. I see plus one from Göran for working group adoption. Marco is saying that he has reviewed the previous version +1 as well. So there seems to be some interest to that. So as I said, Christian, please make an update to the draft so it doesn't expire, and resubmit a version that you can give a brief presentation in Dublin, and then we can decide on the working group adoption there.
Thanks, will do.
All right. Do we have any other business? Göran?
Yeah, I saw Tara in the meeting, so I just thought I'd mention. So there is some people interested in this work. Tara mentioned it in the IETF meeting in Vancouver. There is work in IEEE on key management protocol for ISO 2.15.4, where we have ad hoc as one candidate. There is some interest in that. I don't know how many people are joining the IEEE, but even if you are not, if you're interested, let us know. Then we might have some offline discussion on that. And if you want to say something, Tara, that's fine. Otherwise, we just bring this up to those that are interested.
Sounds good. So people interested in key management for IEEE 802.15.9, I believe, should reach out to Tara and Göran. So with that, I guess we can close the meeting. Any other business? I hear none. So thank you for attending today's interim meeting, and the next meeting will be in Dublin, beginning of November. The chairs have to request the meeting, and I guess we will all see you there. Thank you.
Thanks all.
Thank you.
Thank you.
Thanks. So, Melissa, if you want to hang on for a sec, we can. Do you want me to do the post the notes? Do you want to do that? Do you want me to do the meeting requests? I'll one each.
I can handle that tomorrow, so it's fine. I can post the notes. I've been doing it for the past, so I'm kind of accustomed to it. So it's fine.
Okay, so I'll hit the buttons on a meeting request as well then.
Yeah, you can do the meeting request. Just make sure that the conflicts are updated essentially. And
Yeah.
1 hour. And yes, for me personally, I can't do the Friday afternoon. So
okay.
If we can skip that one, check that one on the list of meetings that we cannot do, that would be appreciated.
So anything except Friday?
Yeah, anything except Friday, exactly.
Sure. I'll do that shortly.
All right. Thanks.
Thanks for setting this up as well. Okay.